Hello everyone! Today I would like to review one of the common MST misconfigurations, which is trunk link pruning. But before we continue, I would like to ask you to subscribe to my channel with notification bell on, and please show your support by hitting like button. So let's do it. This is network diagram which I'm going to use for today's example. We have three switches, SW1, SW2 and SW3, and two VLANs configured on them, VLAN 10 and 20. Four hosts, PC1 and PC4 are in VLAN 10, PC2 and PC3 are in VLAN 20. First I'm going to configure PVST and prune VLAN 20 on this link and VLAN 10 on this link and see how it works. Then I'm going to change STP to MST and do the same with MST. And at the end I'm going to fix issue with VLAN pruning for MST, and I'm going to do configuration how to fix this problem. So let's get started. So let's review what's going to happen when we prune some VLANs on trunk links when we use PVST. For our network, we have VLAN 10 and VLAN 20, and we don't, if we don't touch anything, if we don't prune any VLANs on any links manually, for this example, it's gonna be like this: SW1 root bridge because it has the lowest MAC address, and link G01 is gonna be blocked for all VLANs, VLAN 10, VLAN 20, and for default VLAN 1. But then if we prune VLAN 20 here and VLAN 10 here, nothing happens for VLAN 1. It's gonna work the same. This link is gonna be designated port, this port is designated, this is root port, designated root port, and port and blocking state. But then if we look into VLAN 10 instance, there is no VLAN 10 on this link. So we're gonna have the same, like designated, root, and designated. So traffic is gonna go like this if we have host here and here in VLAN 10. For VLAN 20, it's similar, but then we have this interface designated, this interface designated, root designated, and root. And for VLAN 20, if we prune VLAN 20 here, traffic is gonna go like this if we have hosts in VLAN 20 on SW1 and SW3. So let's check it on our example topology. So let's see what we have. We have PVST at the moment running on all switches, and SW1 root bridge for VLAN 1, root bridge for VLAN 10, and root bridge for VLAN 20. And all ports are designated ports. And let's see SW2. For VLAN 10, G00 facing SW1 is root, and for VLAN 20, G00 also a root port. And SW3 shows spanning tree. We have for VLAN 1 G00 root, G01 blocking alternate, for VLAN 10 same, G00 root, G01 alternate blocking, and for VLAN 20, G00 root and G01 alternate blocking. Let's see our connectivity, ping 10, 0, 10, 4. This is connectivity in VLAN 10, and it's good. And for VLAN 20, 0, 23. And connectivity is good as well. So let's prune VLAN 20 here and VLAN 10 here. On this link, conf t, interface G00, switch port, trunk, allowed VLAN 1 and 10. and interface G01, 1 and 20. Let's wait for convergence. VLAN 1, no changes. VLAN 10, G00 root. And VLAN 20, G01 root, but still learning. So let's wait until it converge. So for VLAN 20, G01 root, this port facing SW2, and for VLAN 10, G00 root, this port facing SW1. So for now, SW1 switch is still a root bridge. So we can configure SW1 as the root primary for VLAN 10 and SW2 root primary for VLAN 20, and this one is going to be for VLAN 1 as well, conf T, but there is no loop because VLANs are pruned, VLAN 20 here and VLAN 10 here. So for this, you're just going to make different topology, because for now we have connectivity. Yes, we have connectivity, and for VLAN 20 traffic is running like this, and for VLAN 10 traffic is running like this. So I want to make this root bridge for VLAN 1 and 10, and this for VLAN 20. Conf T spanning tree, and then VLAN 1 10 root primary, and for VLAN 20 secondary. This switch will be a root for two VLANs, and this one for one VLAN. Conf T spanning tree, VLAN 20 root primary, and spanning tree VLAN 110 root secondary. So now let's check. Show spanning tree. VLAN, this is one root, and VLAN 10 root switch SW1, and for VLAN 20 is not root. Root is SW2 now. Show spanning tree. SW2 is the root bridge only for VLAN 20. So for now we still have connectivity, everything is working fine. Traffic for VLAN 20 running this way, and this is root bridge, and traffic for VLAN 10 running this way, and this is root bridge. Let's check what's gonna happen with MST. So what we have in this situation if we configure MST. The topology in MST is determined by instance, regardless of the VLANs mapped to it. In this example, both VLAN 10 and 20 are mapped to instance 1. And if administrator decides to manually prune VLAN 10 on one uplink, on this one, and VLAN 20 on another uplink, on this uplink, in order to restrict traffic on the uplinks from SW3 to SW1 and SW2, the users on VLAN 20 will have a problem with connectivity. So it happens because VLAN 10 and VLAN 20 are both mapped into the same instance 1, creating only one topology for both VLANs. And load balancing can be achieved here due to manual pruning, and that VLAN 20 is only allowed on blocked port. As you can see, VLAN 10 and VLAN 20 are mapped to one instance, and for this instance, this switch is the root bridge, and this port designated root port, and this port is blocked for this instance. if we prune VLAN 20 here and VLAN 10 here, it means that VLAN 20 from SW3 will not be able to reach switch SW2 and SW1 because it is pruned here and it is in instance 1 and this instance is in blocking state on SW3 on G01 interface. So how to fix it? So to fix this issue and achieve load balancing, VLAN 10 and VLAN 20 must be mapped to different instances. For example, VLAN 10 is mapped to instance 1 and VLAN 20 is mapped to instance 2. And never manually prune VLANs of a trunk. Remove all the VLANs mapped to a given instance together. Never remove individual VLAN from a trunk and not remove all the VLANs that are mapped to the same instance. So let's review this in the example. So again, this is our topology. I removed already spanning tree root bridge for SW1 and SW2 configuration. And we can configure MST. Conf T, spanning tree, mode, MST. And then we do spanning tree, MST configuration. And instance 1, VLAN 10 and 20. Let's go to SW2, conf T, spanning tree mode MST, spanning tree MST configuration, instance 1, VLAN 10 and 20, conf T, spanning tree mode MST, spanning tree MST configuration, instance 1, VLAN 10 and 20. MST configuration. So as you can see, VLAN 10 and 20 mapped into one instance. And let's see what we have with topology. So spanning tree. So this is SW1 is the root bridge for MST0 and it is the root bridge for MST or 1 or instance 1. And I also removed VLAN pruning on these links on the trunks. So let's check what is in SW2. SW2 show spanning tree. So for MST0, for instance 0, G00 interface facing SW1 is the root port and G01 designated. And for MST1, again G00 root and G01 designated. Let's check SW3, show spanning tree. For instance 0, MST0, G00 facing SW1 switch is root and G01 facing SW2 alternate blocking. So this port is blocked for instance 0 and for instance 1 as well. So this port is blocked and this is the root bridge and traffic goes like this. For example, from this host it goes like this because the NSA VLAN 10, and from this host it goes like this because it is in VLAN 20 and we haven't pruned anything yet. So let's prune VLAN 20 from this interface and VLAN 10 from this one. Conf T, interface G00, switch port, trunk, VLAN, allowed VLAN, 1 and 10, and interface G01, switch port 20. And let's see what's going to happen. Show spanning tree. Okay, G00 for MST 0 root, G01 alternate. For MST1 root bridge is still SW1, and G01 root, G00 root port, and G01 alternates. So situation still the same. And let's see what we have here. Show spanning tree. G00 root, G00 root. And for this one, everything designated because this is a root bridge. Designated, and this is root bridge, and this is root bridge. So let's check our traffic ping 10, 0, 10, 4. We have traffic for VLAN 10 because it goes this way, and VLAN 10 is allowed on this link, and this link is this port is G00 is root port on SW1. And let's see for PC2 ping 10, 0, 23, and there is no connectivity between PC2 and PC3. They are in VLAN 20. This link is blocked for instance 1, and these two VLANs, they are mapped into instance 1, and on this link VLAN 20 is pruned, so traffic cannot go as it was before this way, because there is no VLAN 20 here, and here VLAN 20 instance 1 is pruned, so there is no way for traffic from PC2 reach PC3. So to fix this, we can map instances in VLANs into different instances. Let's do it. Conf t spanning tree MST configuration instance 2 VLAN 20, and let's go to SW2 conf t spanning tree MST configuration instance 2 VLAN 20, and the last one conf t spanning tree configuration MST configuration instance 2 VLAN 20. Show spanning tree MST configuration, and as you can see, now we have different situation. We have instance 0, 1, 2, instance VLAN 10 mapped into instance 1 and 20 into instance 2. Show spanning tree. Let's see what we have now. For instance 0, nothing changed. For instance 1, still has not converged. We need to wait. For MST2, G01 blocking and G03 designated, so still we need to wait. Let's see what's happening here. Designated, 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 designated. Good. Root designated and blocking. Instance 1 root and instance 2 root G00 and G01 forwarding. Let's see again here. Instance 1 G00 forwarding and instance 2 G01 facing SW2, now a root port and forwarding. So what happened for now on this switch SW3 for instance 1, this is the root port, and for instance 2 this is the root port. So now we should have connectivity between PC2 and PC3 because it will pass to this way. Here there is no VLAN 20. And let's see. for VLAN 10 everything is good, and for VLAN 20 everything is good. So, and now we can configure SW1 to be root bridge for VLAN for instance 1 and SW2 to be the root bridge for instance 2. Conf t spanning tree MST, and then we need to do 1 root primary and instance 2 root secondary. Let's do SW2 conf t spanning tree MST 1 root secondary and spanning tree MST 2 root primary. Let's wait for convergence. So this is the root bridge for instance 1, and it is not a root bridge for instance 2. G01 facing SW2 is the root bridge now. Oh, root port, sorry. And show spanning tree. SW2 still has G00 facing SW1 as the root port, and for instance 1 and for instance 2, this is the root bridge. So this one is root bridge for instance 1, and this SW2 switch is root bridge for instance 2. Let's see if we still have connectivity. Yes, we have connectivity in VLAN 10 and we have connectivity in VLAN 20. So for instance 1, where VLAN 10 is mapped, traffic goes like this, and for instance 2, where VLAN 20 is mapped, traffic goes like this, and this is the root bridge for instance 2, and this is the root bridge for instance 1. So that was everything for misconfiguration, MST misconfiguration with pruning trunk links. Thank you very much for your attention.
Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.